What is metamathematics?
Metamathematics is the study of mathematical reasoning in a general and abstract way. Usually by trying to understand how theorems are derived from axioms. Thus, it is often called proof theory. For more information about axioms, see below. It does not study the objects of a particular mathematical theory, but examines the mathematical theories themselves with respect to their logical structure. Metamathematics is also used in logic to study the combination and application of mathematical symbols. This is often referred to as metalogic.
What is an example of the second derivative?
The second derivative is actually a function's derivative's derivative. In other words, the function's derivative may also have its own derivative, called the second derivative or second-order derivative. If we let y equals f, x, the second derivative becomes d/dx, dy/dx. This is equal to d2y/dx2, further represented by the symbols f, x, or y. One good example of a second-order derivative is acceleration. It is actually the second derivative of a change in distance. In other words, the first derivative gives instantaneous velocity. See above, while the second derivative gives acceleration. This equation is also seen written as dn, y, equals dny/dxn.
How does one calculate resting heart rate?
Calculating resting heart rate, RHR, involves easy math. It is the number of heartbeats per minute when the body is resting, with the beats per minute representing the number of times the heart contracts. To measure the RHR, just count the number of beats per minute via the pulse, usually taken either on the inside of the wrist or along either side of the neck for 15 seconds. Then multiply this number by 4, 15 x 4 equals 60 seconds, to get the heart rate per minute. Or count for 10 seconds, then multiply this number times 6. 6 x 10 equals 60 seconds, to get the heart rate per minute. For example, if you count 12 beats in 10 seconds, multiply 12 by 6 to get a resting heart rate of 72.
How did Pierre-Simon de Laplace apply mathematics to astronomy?
French mathematician, astronomer, and physicist Marquis Pierre-Simon de Laplace, 1749 to 1827, was one of the first to work out the gravitational mechanics of the solar system using mathematics. In his Mécanique céleste, celestial mechanics, Laplace translated the geometrical study of mechanics used by Isaac Newton to one based on calculus, or physical mechanics. He also proved the stability of the solar system, but only on a short time scale. Laplace is also known for his theory about the formation of the planets. He believed they originated from the same primitive mass of material. A theory now known as Laplace's nebular hypothesis. His other studies included major contributions to differential equations and to the theory of probability.
How does one calculate heart rate during exercise?
One reason to calculate heart rate during exercise is to know if a person is getting beneficial exercise to keep the heart and body healthy. In order to determine the safe and effective range of exercise to get cardiovascular benefits, two measurements are often taken. The first is the maximal heart rate, a number related to a person's age. The heart beats slower with age. To estimate the maximal heart rate, subtract a person's age from the number 220. For example, if someone is 40 years old, his or her maximal heart rate is 180. The next measurement is the target heart rate zone. This number uses the maximal heart rate and represents the number of times per minute at which a heart should be beating during aerobic exercise. For most healthy people, the range is 50% at the lower limit to 80, some charts say 75% at the upper limit of their maximal heart rate. When a person's heart rate reaches a value within this zone during exercise, it means he or she has achieved a level of activity that contributes to his or her cardiovascular fitness. For instance, from the above example of a maximal heart rate of 180, the beats per minute for the lower range would be 180 multiplied by 50%, 0.50, or 90 beats per minute. The upper range would be 180 multiplied by 80%, 0.80, or 144 beats per minute. If you work out and maintain a lower than 50 or higher than 80% limit, there are few beneficial effects from the exercise. In terms of the lower limit, the heart is not working hard enough for any cardiovascular benefit. In terms of the upper limit, besides the strain and injuries that can result, the heart is working too fast for any benefit and the body can't replenish oxygen that quickly.
How do scientists measure the Earth's rotational speed?
The Earth's rotational speed is based on the sidereal period of the Earth's rotation, but it differs depending on where the observer is located. By dividing the distance traveled once around the Earth by the time it takes to travel that distance, the speed can be determined. For example, a person on the Earth's equator will travel once around the Earth's circumference, or 24,900 miles, 40,079 kilometers, in one day. To get the speed, divide the miles by the time it takes to get back to the same place. Around 24 hours, or just over 1,000 miles, 1609 kilometers per hour. A person at one of the poles is hardly moving at any speed. This is because there is so little distance traveled in a day. A stick stuck vertically in the ice exactly at the north or south pole will only travel about 0.394 inch 1 centimeter per day.
What does a plane mean in geometry?
A plane in geometry or any other field of mathematics means a surface such that a straight line joining any two of its points lies totally in that surface. A plane is considered to be two-dimensional. When a plane is discussed with higher dimensions, it is called a hyperplane. Thus, in the majority of mathematical discussions, a plane can be thought of as a two-dimensional group of points that reach out to infinity in all directions. For more information about dimensions, see above.
How do modern cash registers automatically know how much an item costs?
Modern cash registers are actually computers that are able to read a code consisting of a series of vertical bars varying in width. These are called barcodes, or barcode, and represent numbers and other symbols. The barcode is scanned by a laser beam that is sensitive to the reflections from the line along with space thickness and variation. The reader translates the reflected light into digital data that is transferred to a computer for immediate action or storage, usually both resulting in the addition of items purchased and an immediate inventory for the store. For more information about computers, see Math in Computing. But barcodes aren't only for stores. They are also used to check out books from the library, identify hospital patients, and track manufacturing and shipping movements. There are even very small barcodes used in scientific research. For example, to tag and keep track of honeybees.
Can all quadratic equations be solved by factoring?
Don't be fooled, not all quadratic equations can be solved by factoring. For example, x23x equals 3 is not solvable with this method. One way to solve quadratic equations is by completing the square. Still another method is to graph the solution. A quadratic graph forms a parabola, a U-shaped line seen on the graph. But one of the most well-known ways is by using the quadratic formula. For example, if we want to find the roots of the polynomial x2 plus 2x7, we can replace the corresponding numbers from the initial equation into the quadratic equation x2 plus bx plus c equals 0. Thus, a equals 1, b equals 2, and c equals -7.
Who was Pierre de Fermat?
French mathematician Pierre de Fermat, 1601–1665, made many contributions to early methods leading to differential calculus. He was also considered by some to be the founder of modern number theory. See Math Basics, and did much to establish coordinate geometry, eventually leading to Cartesian coordinates. He supposedly proved a theorem eventually called Fermat's last theorem. It states that the equation xn plus yn equals zn has no non-zero integer solutions for x, y, and z when n is greater than 2. But there is no proof of Fermat's proof, making most mathematicians skeptical about his supposed discovery.
What is a polar coordinate system?
In effect, a polar coordinate system wraps a two-dimensional, Euclidean, coordinate system onto the surface of a sphere. For more information about coordinate systems, see geometry and trigonometry. A polar coordinate system examines a point in space defined in terms of its position and distance on a sphere with a unit radius. The center of the sphere is considered the origin. The first two coordinates are the longitude and latitude on the sphere, the third coordinate defines the distance of the point from the center of the sphere, the values of latitude, longitude, and height. In polar coordinates, it's easy to see on a globe of our own planet latitude ranges from +90 to -90, longitude ranges from -180 to +180, and height ranges from 0 to infinity.
What are some common modern measurement systems?
There are several measurement systems in use today. The English customary system is also known as the standard system. US customary system, or units, or English units. It actually consists of two related systems, the US customary units and the British imperial system. The background of the units of measurement is historically rich and includes modern familiar terms, such as foot, inch, mile, and pound, as well as less well-known units, such as span, cubit, and rod. The official policy of the United States government is to designate the metric system as the preferred system for trade and commerce. But customary units are still widely used on consumer products and in industrial manufacturing. In order to link all systems of weights and measures, both metric and non-metric, there is a network of international agreements supporting what is known as the International System of Units. It is abbreviated as SI, but not SI. In reference to the first two initials of its French name, Système International des Unités. It was developed from an agreement signed in Paris on May 20, 1875, known as the Treaty of the Meter, Convention du Meter. To date, 48 nations have signed the treaty. The SI is maintained by a small agency in Paris, the International Bureau of Weights and Measures. BIPM, or Bureau International d'études et mesures. Because there is a need to change or update the precision of measurements over time. The SI is updated every few years by the International General Conference on Weights and Measures, or CGPM, or Conference Générale d'études et mesures, the two most recent meetings being in 2003 and 2007. SI is also referred to as the metric system, which is based on the meter. The word can also be used in mathematics, for example, metric space, or even computing, font metric file. It is often referred to incorrectly as metrical. See below for more about the metric system.
How are mathematics and the study of time connected?
Mathematics is definitely tied to time. There has long been a need in human civilizations to record many sequences of events, especially those in nature that affected people. For example, the changing of the seasons was important to know, as it influenced the planting and growing of crops, when rivers would flood, and even when weather would change from monsoon rains and harsh droughts to potential blizzards. The first such timekeepers counted the changing days and years by the movement of stars, the sun, and the moon across the sky, all of which are activities that included simple mathematical calculations.
What is a store discount?
Many stores, from apparel shops to bookstores, offer a discount on the retail price or, less often, on the sale price. For example, say a sweater that originally costs $50 is discounted by 25% during a sale at a department store. The customer will actually pay 75%, or 75/100 or 0.75, of $50, to determine the sale price. Multiply $50 by 25%, 50x 0.25 equals 12.50. Then subtract the discount from the original price to find the sale price, or $50. $12.50 equals $37.50.
Who first calculated the distance from the Earth to the Sun and Moon?
Around 290 BCE, astronomer and mathematician Aristarchus of Samos, c. 310 BCE to c. 230 BCE, used geometric methods to calculate the distances to and sizes of the Moon and Sun. Based on his observations and calculations, he suggested that the Sun was about 20 times as distant from the Earth as the Moon. It is actually 390 times. He also determined that the Moon's radius was 0.5 times the radius of the Earth. It is actually 0.28 times. The numbers differ not because Aristarchus had no geometric knowledge, but because of the poor instruments used at that time. These calculations were not the only contribution made by Aristarchus. He was also the first to propose that the Earth orbits the Sun many centuries before Nicolaus Copernicus, see below. This concept was radical for his time, because it conflicted with geocentric religious beliefs and Aristotle's principle that all objects move toward the center of the Earth.
What are some simple rules of exponents?
There are several simple rules when it comes to exponents. These include the following: the equation x1 equals x, or a number raised to the 1 power is the number itself. This is also called the rules of 1. The equation x0 equals 1, unless x equals 0, which is considered undefined. This is also called the zero rule. A number without an exponent has an exponent of 1, as in 20 equals 201. A negative exponent indicates that the number is to be divided by the exponent instead of multiplied. For example, 3 to 3 is equal to 1/33, or 1/27. But there is a restriction to this rule. Xn equals 1/xn only when x is not 0, if x is 0, then xn is undefined.
How does a person calculate sales tax on purchases?
Most states and cities charge sales tax on retail purchases made by customers, from clothes to certain foods. This sales tax is based on a percent of the purchase price, with the percentage of tax called the tax rate. In turn, each state's tax rates vary greatly, often with the counties charging additional taxes. For example, in Vermont, the state and local sales tax rate stands at 5%. Florida has a state sales tax rate of 6%. And in various counties of New York, the sales tax rates start as low as 7.25% to as high as 8.75%.
Who was Charles Babbage?
English inventor and mathematician Charles Babbage, 1792 to 1871. Is considered by some historians to be the father of computing. The main reason was his analytical engine, which is thought to be the true precursor of the modern computer.
Who was Carl Friedrich Gauss?
German mathematician, physicist, and astronomer Carl Friedrich Gauss, 1777 to 1855, also seen as Johann Carl or Carl Friedrich Gauss, was considered one of the greatest mathematicians of his time. Some have even compared him to Archimedes and Newton. His greatest mathematical contributions were in the fields of higher arithmetic and number theory. He discovered the law of quadratic reciprocity, determined the method of least squares. Independently of French mathematician Adrien-Marie Legendre (1752–1833), popularized the symbol I as the square root of -1, although Euler first used the symbol. Did extensive investigations in the theory of space curves and surfaces, made contributions to differential geometry, and much more. In 1801, after the discovery, and subsequent loss, of the first asteroid, Ceres, by Giuseppe Piazzi, he calculated the object's orbit with little data. The asteroid was found again thanks to his calculations. He further calculated the orbits of asteroids found over the next few years.
What was the problem with the lunar-based calendars?
Nothing is perfect, especially a lunar month. The biggest drawback with using a lunar calendar is the fractional number of days, which makes a lunar calendar quickly go out of sync with the actual phases of the moon. The first month would be off by about a half a day, the next month a day, the next month a day and a half, and so on. One way to help solve the problem was to alternate 30 and 29-day months. But this, too, eventually made the calendars go out of sync. To compensate, certain cultures added intercalations or subtracted extracalations days from their calendar. For example, for more than 1,000 years, the Muslims' lunar calendar has had an intercalation of 11 extra days over a period of 30 years, with each year being 12 lunar months. This calendar is only out of sync about 1 day every 2,500 years. To see this, mathematically speaking, the average length of a month over a 30-year period is figured out with the following equation: 29.5 x 360 plus 11/360 equals 29.530556 days, in which 11 is the number of intercalated days. 360 is the number of months in a 30-year cycle, 12 months x 30 years. And 29.5 is the average number of days in the calendar month, or 29 plus 30/2.
What is Zermelo's axiom of choice?
Talk. It sounds like something on a Greek restaurant menu. Zermelo's axiom of choice is actually a fundamental axiom in set theory. It states that given any set of mutually exclusive non-empty sets, there is at least one set that contains exactly one element in common with each of the non-empty sets. This was actually one of David Hilbert's problems that needed to be solved by mathematicians of his day. For more about David Hilbert, see earlier in this chapter, and in History of Mathematics. German mathematician Ernst Friedrich Ferdinand Zermelo, 1871–1953, took on the task. And in 1904 he developed what is called the well-ordering theorem. which says every set can be well ordered based on the axiom of choice. This brought fame to Zermelo, but it was not accepted by all mathematicians who balked at the lack of axiomatization of set theory. For more about axiomatic set theory, see above. Although he finally did axiomatize set theory and improve on his theorem, there were still gaps in his logic, especially since he failed to prove the consistency in his axiomatic system. By 1923, German mathematician Adolf Abraham Halevi Frankel, 1891–1965, and Norwegian mathematician Albert Thorolf Skolem, 1887–1963, independently improved Zermelo's axiomatic system, resulting in the system now called Zermelo-Frankel axioms. Skolem's name was not included, although another theorem is named after him. This is now the most commonly used system for axiomatic set theory.
What is a group in abstract algebra?
A group, usually referred to as G, is a finite or infinite set of elements together with a binary operation, often called the group operation, that together satisfy the four fundamental properties: closure, associativity, and the identity and inverse properties. For more information about these properties, see elsewhere in this chapter. A great many of the objects investigated in mathematics turn out to be groups, including familiar number systems such as the integers, rational, real, and complex numbers under addition, non-zero rational, real, and complex numbers under multiplication, non-singular matrices under multiplication, and so on. The branch of mathematics that studies groups is called group theory. An important area of mathematics that has many applications to mathematical physics, such as particle theory.
How did our present day become divided into hours, minutes, and seconds?
Divisions into hours, minutes, and seconds probably began with the Sumerians around 3000 BCE. They divided the day into 12 periods, and the periods into 30 sections. About 1000 years later, the Babylonian civilization, which was then in the same area as the Sumerians, broke the day into 24 hours. Europe around 20,000 years ago recorded days between successive new moons. Another hypothesis states that the measurement of time dates back some 10,000 years, which coincides with the development of agriculture, especially in terms of when to best plant crops. Still others point to timekeeping evidence dating back 5,000 to 6,000 years ago around the Middle East and North Africa. Whatever the true beginnings, most researchers agree that timekeeping is one of those subjects whose history will probably never be accurately known.
What is the Monte Carlo method?
The Monte Carlo method gives approximate numerical solutions to a number of problems that are too difficult to solve analytically by performing specific statistical sampling experiments. Although forms of the method have been known for a while, it was initially developed for numerical integrations in statistical physics problems during the early days of electronic computing. It was named after the city in the Monaco Principality, some say, because of the simple random number generator of roulette played in the Monaco casinos. Others say the method's creator was honoring a relative who had a propensity toward gambling. But there is more to the Monte Carlo method than meets the computation. For one thing, there is more than one Monte Carlo method. For example, one method, called the Markov chain Monte Carlo method, has played a critical role in such diverse fields as physics, statistics, computer science, and structural biology. And the list of applications continues, as recently as the late 1990s. Researchers and statisticians began to realize the usefulness and power of Monte Carlo methods for prediction.
How is the product of two vectors determined?
There are two distinct types of products of two vectors, scalar and vector products. Sometimes called the inner and outer products, mostly in reference to tensor products, see below. The scalar, or dot, product of two vectors is not a vector, because the product has a magnitude but not a direction. For example, if A and B are vectors, of magnitude A and B, respectively, their scalar product is, AB equals ab cos 8, in which 8 is the angle between the two vectors. This scalar quantity is also called the dot product of the vectors. These equations obey the commutative and distributive laws of algebra. For more information, see algebra. Thus, AB equals BA, A, B plus C, equals AB plus AC. If A is perpendicular to B, then AB equals 0. The vector, or cross or skew, product of A and B is the length C equals ab sin 8, its direction is perpendicular to the plane determined by A and B. In this case, this kind of multiplication does not follow the commutative law, as AB equals BA.
What is Gödel's incompleteness theorem?
Austrian-American mathematician and logician Kurt Gödel, 1906 to 1978, is best known for his studies in mathematical logic, in particular, his incompleteness theorem, presented in 1931. This theorem shows that an infinite number of propositions that can't be derived from axioms of a system may be proved by metamathematical means external to mathematics. In other words, mathematics abounds with questions that have a yes or no nature. The incompleteness theory suggests that such questions will always exist. For more about Gödel, see History of Mathematics.
What is differential calculus?
Differential calculus is the part of the calculus that deals with derivatives.
What is analytic geometry?
Analytic geometry is actually another name for coordinate, or Cartesian, geometry. A way to geometrically represent ordered pairs of numbers, or coordinates. The objects are described as n tuples of points, in which n equals 2 in a plane and n equals 3 in a space. Or 2 and 3 dimensions, in some coordinate system. Overall, analytic geometry allows mathematicians to determine the position, configurations, and separations of objects using algebraic representation and manipulation of equations.
Why was the Bernoulli family important to mathematics?
The Bernoulli, also seen as Bernoulli, family of the 17th and 18th centuries is synonymous with mathematics and science. One of the developers of ordinary calculus, calculus of variations. And the first to use the word integral was Jacob Bernoulli, 1654 to 1705, also known as Jacob, Jacques, or James. He also wrote about the theory of probability, is often credited for developing the field of statistics, and discovered a series of numbers that bear his name. The coefficients of the exponential series expansion of x/1ex. Not to be outdone, his brother Johann, 1667 to 1748, also known as Jean or John, contributed to the field of integral and exponential calculus. Was the founder of calculus of variations, and worked on geodesics, complex numbers, and trigonometry. His son was not far behind. Daniel Bernoulli, 1700 to 1782, was considered the first mathematical physicist. Publishing Hydrodynamica in 1738, which included his now famous principle named in his honor. Bernoulli's principle, and he brought out two ideas that were ahead of his time by many years: the law of conservation of energy and the kinetic molecular theory of gases. The Bernoulli legacy did not end there. With family members continuing to make great mathematical and scientific contributions. There were two Nicolaus Bernoullis, one, the brother of Jacob and Johann. 1662 to 1716, was professor of mathematics at St. Petersburg, Russia's Academy of Sciences, the other. The son of Johann and brother of Daniel, 1695 to 1726, was also a mathematician. Another Johann Bernoulli, 1710 to 1790, was another son of Johann, and brother of Daniel, who succeeded his father in the chair of mathematics at Basel, Switzerland, and also contributed to physics. The younger Johann also had a son named Johann, 1746 to 1807, who was Astronomer Royal in Berlin and also studied mathematics and geography. Finally, Jacob Bernoulli, 1759 to 1789, yet another son of the younger Johann, succeeded his uncle Daniel in teaching mathematics and physics at St. Petersburg, but he met an untimely death by drowning.
What is fluid mechanics?
Fluids are substances that flow, including gases and liquids. Fluid mechanics, or hydraulics, is the study of the physical behavior of these gases and liquids and their role in engineering systems. This includes the mathematics of the forces in and motion of substances, turbulence, wave propagation, and so on. Most fluid mechanics problems in engineering are mathematically modeled using differential equations. These models can also be applied to other engineering areas, such as electromagnetism and the mechanics of solids, because solids still move, albeit slowly. Other fluid mechanical studies include the compressibility of substances. In most cases, liquids are considered to be incompressible and gases are considered to be compressible. But there are exceptions in some everyday engineering applications, and they can easily be explored using mathematical modeling. Engineers also use special mathematical equations to determine certain characteristics of fluid flow, such as whether the flow is slow and smooth, laminar, or turbulent. For example, the ratio of inertia forces to viscous forces within a fluid can be expressed by what is called the Reynolds number. Laminar fluid flow can be described by the Navier-Stokes equations. For no viscosity, or an ideal flow called inviscid flow, the Bernoulli equation can be used. Finally, when the flow is zero, or static, the fluid is governed by the laws and equations of fluid statics.
What is a tangram?
Some puzzle forms go back thousands of years, such as the tangram, which is also known as a dissection puzzle. The tangram is of Chinese origin, literally called the seven board of cunning, but the word itself is of English origin, and is built from the words tang, thought to be a synonym for Chinese in the Cantonese dialect, and gram. It is thought that the Pythagorean theorem was discovered in Asia before Pythagoras' time with the help of tangram pieces. For more about the Pythagorean theorem, see geometry and trigonometry. The tangram consists of a square divided into 7 pieces called tans, all of which must be arranged to match particular designs, usually a square.
What is money?
Actually, money is a mathematical concept. In each culture, money, or currency, is the most common medium of exchange. and through an agreement within a community it can be traded and exchanged for goods, services, or obligations. Each type of currency represents specific units that can be subdivided, such as dollar bills and quarters. A good or service is then given a certain value when compared to other goods and services. What is usually referred to as a price. Because of this, people who use money need to know some of the most basic of mathematical concepts, especially addition and subtraction. Of course, money is actually an abstraction. Now and over the centuries, it has been essentially a token. That is why money has often been represented by such things as naturally scarce precious metals, such as gold and silver, conch shells, trinkets, and today's entirely artificial representation of money, paper banknotes.
What are the various types of polyhedra?
As with most forms, polyhedra are divided into many names, depending on the number of faces.
How are points determined in a real estate transaction?
Hen buying a home through a real estate group or bank. Points may be paid by the borrower at the time a loan is made. This is usually to get a lower interest rate. Because the lender often offers certain rate/point combinations that may help the homeowner save money. Actually, points usually refer to the commission charged by the mortgage broker or the loan fee charged by the lender when the loan is made. Points can be also negative, in which case they are called rebates from the lender to the borrower and are often used by borrowers to defray other settlement costs. In general, each point is 1% of the loan amount. For instance, 3 points would be equal to 3% of the total loan amount. There is no set number of points offered by a lender, as it is not controlled by any laws. For example, on a $100,000 loan, 1 point is equal to $1,000, 10 points is equal to $10. 000. A homeowner looking for a loan should try to find a mortgage broker or lender that charges fewer points. Some financial institutions might even be willing to negotiate for lower points. But beware of lenders offering no or 0 points, because they usually charge much higher interest rates than those offering loans with points. Although it is a matter of mathematics and a person's budget, there are some very general guidelines when choosing a mortgage. Low-rate, high-point loans are usually used by borrowers who can meet the down payment cash requirement and either want to stay in a house a long time or want to reduce their monthly mortgage payments. High-rate, low-point combinations are for borrowers who don't expect to be in their houses very long, or who are short on cash.
What is the difference between the various pounds and ounces?
The story behind the ounce is long and convoluted because historically people have been dissatisfied with the unit. For example, in medieval times English merchants were not happy with the troy pound, as it was less than the commercial pound in most of Europe. In response, the merchants developed an even larger pound, which was called the libra mercatoria, or mercantile pound. But by 1300 the complaints about the mercantile pound grew, because 15 troy ounces, or 7,200 grains, were easily divided by 15 and its divisors, but this was not as convenient as dividing by 12 troy ounces. Soon, another type of pound was born in English commerce, the 16-ounce avoirdupois. Roughly translated from the Old French as goods of weight. Modeled on a common Italian pound unit of the late 13th century. The avoirdupois pound weighed exactly 7,000 grains, which is easily divided for use in sales and trade. But because it was difficult to convert between the troy and avoirdupois units, the avoirdupois ounce is 7,000/16, or 437.5 grains, and 1 grain equals 1/7,000 avoirdupois pound, or 1/5,760 troy or apothecaries pound. The troy ounce is 5,760/12,480 grains, or 31.1035 grams in metric. The standard soon shifted to using mostly the avoirdupois unit. The avoirdupois is currently used in the United States and Britain. It is equal to 1/16 of a pound, or 28.3495 grams, in metric. The avoirdupois ounce is further divided into 16 drams, or dram. The troy ounce hasn't been totally forgotten, though. Today, it is used mainly as units for precious metals and drugs, where it is often called the apothecary's ounce. With its subdivisions of the scruple, or 20 grains, and the dram, or 60 grains. In turn, the avoirdupois hour ounce for short is used for almost everything else.
What is modern physics?
In contrast to classical physics, although there are overlapping topics, modern physics includes relativistic mechanics, atomic, nuclear, and particle physics, and quantum physics.
What mathematical concept was featured in the movie The Andromeda Strain?
The concept of exponential growth, also known as geometric growth, provided the tension in this movie and the book on which it was based. The basic premise was that microscopic organisms had been inadvertently brought to Earth from outer space by a returning satellite. Once on Earth, they reproduced exponentially, doubling in number every 20 minutes. Very quickly, they spread over the entire planet, killing nearly everyone. And no, we won't give away the ending.
Are there higher derivatives of a function?
Yes, there are higher derivatives of a function, often referred to as higher order derivatives. The initial derivative is often written as f, x, but the is assumed in most cases. The next derivative is the second derivative, second order derivative, most often written as f, x. The next is the third derivative, or third order derivative, most often written as f, x. Fourth derivative, or fourth order derivative, most often written as f, 4, x, and so on.
Who first determined the value of pi?
People have been fascinated by pi throughout history. It was used by the Babylonians and Egyptians. The Chinese thought it stood for 1,000 years. Some even give the Bible credit for mentioning the concept of pi, in which it apparently equaled 3. In one biblical version of I Kings 7, 23-26, it states, "And he made a molten sea, 10 cubits from the one brim to the other, it was round all about. And his height was 5 cubits, and a line of 30 cubits did compass it about." The same verse is found in 2 Chronicles 4, 2-5 in reference to a vessel. C. Made in the Temple of Solomon, which was built around 950 BCE. No one truly knows the origins of pi. Although many historians believe it was probably figured out long ago. There are some clues as to its discovery, though. For example, some people claim the Egyptian Rhind papyrus, also called Ams papyrus, which was transcribed about 1650 BCE by Ams, an Egyptian scribe who claimed he was copying a 200-year-old document, contains a notation that pi equals 3.16, which is close to the real value of pi. For more about the Rhind papyrus, see History of Mathematics. But it was the Greeks who promoted the idea of pi the most. They were very interested in the properties of circles, especially the ratio of a circle to its diameter. In particular, Greek mathematician Archimedes, c. 287-212 BCE, Hellenic, computed close limits of pi by comparing polygons inscribed in and circumscribed about a circle.
What are some terms used in the Cartesian coordinate system and graphs?
There are numerous terms used in the Cartesian coordinate system. Besides the ones already mentioned, the following are some of the most common. An intercept is a point's distance on a coordinate system axis from the origin to where a curve or surface intersects the axis. On a graph, the x-intercept and y-intercept are two important features that show where a line cuts through the x and y axes, respectively. The origin is the fixed point from which measurements are taken. In most cases, especially in a standard simple two-dimensional Cartesian coordinate system, this means the point that represents 0. This is often seen as 0, 0, or the point in which the x and y axes intersect on a graph. In a three-dimensional system, the coordinates are often seen as 0, 0, 0. A Cartesian plane, or coordinate plane, is described as a two-dimensional space made up of points that are identified by their relation to the origin, 0, and the x and y axes. An axis, the plural is axes, is a reference line used in a graph or a coordinate system, such as the Cartesian system. For example, the x-axis and y-axis are perpendicular lines on a graph in a two-dimensional system. In a three-dimensional system, they are the x-axis, y-axis, and z-axis. Collinear points are those that lie on a straight line. Any 2 points are considered collinear because a straight line passes through both. Many procedures in analytic geometry involve determining the collinear points that represent coordinates that solve an equation. Logically, those points that do not lie on the same line, or, in other words, that do not solve the equation, are called noncollinear points.
What is a ring?
A ring is an algebraic structure, some definitions say a set, in which two binary operators, addition and multiplication, in various combinations must satisfy either the additive associative, commutative, identity, and inverse properties. The multiplicative associative property, or the left and right distributivity properties. For example, the elements of one operation, such as addition, must form a group that is commutative, also known as an abelian group. The multiplicative operation must produce unique answers that have the associative property. These two operations are further connected by requiring the multiplication to have a distributive property with respect to the addition. This can be written as follows, with A, B, and C elements of the ring. AX, B plus C, equals, AXB, plus, AXC, and, B plus C, XA equals, BXA, plus, CXA.
Where does most of our knowledge of Egyptian mathematics originate?
Most of our knowledge of Egyptian mathematics comes from writings on papyrus, a type of writing paper made in ancient Egypt from the pith and long stems of the papyrus plant. Most papyri no longer exist, as the material is fragile and disintegrates over time. But two major papyri associated with Egyptian mathematics have survived. Named after Scottish Egyptologist A. Henry Rhind, the Rhind papyrus is about 19 feet, 6 meters, long and 1 foot, 1/3 meter, wide. It was written around 1650 BCE by Ams, an Egyptian scribe who claimed he was copying a 200-year-old document. Thus the original information is from about 1850 BCE. This papyrus contains 87 mathematical problems, most of these are practical. But some teach manipulation of the number system, though with no application in mind. For example, the first 6 problems of the Rhind papyrus ask the following. Problem 1. How to divide n loaves between 10 men, in which n equals 1, in problem 2, n equals 2. In problem 3, n equals 6, in problem 4, n equals 7, in problem 5, n equals 8, and in problem 6, n equals 9. In addition, 81 out of the 87 problems involve operating with fractions, while other problems involve quantities and even geometry. Rhind purchased the papyrus in 1858 in Luxor. It resides in the British Museum in London. Written around the 12th Egyptian dynasty, and named after the Russian city. The mathematical information on the Moscow papyrus is not ascribed to any one Egyptian, as no name is recorded on the document. The papyrus contains 25 problems similar to those in the Rhind papyrus, and many that show the Egyptians had a good grasp of geometry, including a formula for a truncated pyramid. It resides in the Museum of Fine Arts in Moscow.
What are some basketball statistics?
One of the main ways a National Basketball Association coach evaluates a player's game performance is by efficiency, which is determined by using the formula, points and rebounds and assists and steals and blocks. Field goals attempted, field goals made, plus, free throws attempted, free throws made, plus turnovers. Field goal percentage, FG%, is determined by the field goals made. FGM, divided by the field goals attempted, FGA. Finally, the free throw percentage, FT%, is determined by the number of free throws made, FTM, divided by the free throws attempted, FTA.
How else is mathematics used in physics?
There are hundreds of other applications of mathematics in physics.
What is a system of equations?
System of equations is any set of simultaneous equations two or more that are intertwined and have to be determined together. They are usually a finite set of equations with the same unknowns, all of which have common solutions. A set of linear equations is said to be a linear system, while a set of homogeneous linear equations is called a homogeneous linear system. The number of equations is finite, meaning the solutions don't go on forever like some with billions of answers. But a word of caution, Some problems use systems with hundreds of equations and just about the same number of variables.
What is a stomachion?
A stomachion is a dissection puzzle similar to a tangram. It uses 14 pieces in the puzzle, each of varying polygonal shapes and arranged into a 12 by 12 square grid. Each of the pieces has an area that is an integral fraction, for example, 24, 12, 9, 6, or 3, of the total area of the square, which is 144 units. The object of a stomachion is to arrange the pieces into interesting and often recognizable shapes, such as people, animals, and objects. This puzzle was also an ancient game known to the Greek mathematician Archimedes, c. 287 to 212 BCE, and thus is also called the loculus of Archimedes, Archimedes' box. It is doubtful Archimedes invented the puzzle, but he did explore its geometric aspects. It also now appears that in contemplating the different solutions to this puzzle, Archimedes actually was anticipating the branch of mathematics we now call combinatorics.
Why do meteorologists want people to pay attention to the heat index?
The major reason involves how the body responds to high heat value numbers. If the relative humidity is high, it curtails evaporation on the skin, and the body is unable to effectively cool itself, and a person will perceive that the air is warmer. When heat index values grow higher, conditions exceed the level a body can remove heat, causing the body temperature to rise. This can cause heat-related illnesses, such as sunstroke or heat exhaustion. For example, according to the United States National Weather Service, exposure to direct sunlight can increase the high by up to 15 degrees Fahrenheit, 9.4 degrees centigrade. And when a heat index between a mere 90 degrees Fahrenheit, 32.2 degrees centigrade, to 105 degrees Fahrenheit, 40.6 degrees centigrade, can cause possible sunstroke, heat exhaustion, and heat cramps, it is easy to see the meteorologist's concerns. The following table shows how the heat we actually experience changes with temperature and humidity. Humidity is expressed as a percentage, temperatures are in degrees Fahrenheit. According to the National Weather Service, sunstroke, heat cramps, and heat exhaustion are possible above 90 degrees Fahrenheit. Temperatures above 105 degrees can also lead to heat stroke, and above 130 degrees heat stroke is likely if exposure to such temperatures is prolonged.
How can people calculate their age and weight on other planets?
It is certainly possible to find a person's age and weight on another planet without actually having to travel there. To figure out weight, one just needs to know the gravitational pull on another planet, moon, or other space body. For example, based on the chart below, if a person weighed 100 pounds on Earth, he or she would weigh 38 pounds on Mercury, 100 x 0.38. A person's age on Earth depends on how many times the planet has orbited the Sun during his or her lifetime. For example, a person 30 years old has traveled around our star 30 times. In order to work out how old a person is on another planet, the person's age has to be divided by the period of revolution, in terms of Earth years. Thus, if the same 30 Earth-year-old person lived on Saturn, he or she would be just over 1 Saturn-year-old, 30/29.5 equals 1.02 Saturn years. On Mercury, the person would be 124.5 Mercury years old, 30/0.241 equals 124.5 Mercury years.